RockTrue Science is a cross-cultural response to the lack of diversity in STEM fields. STEM stands for science, technology, engineering, and mathematics. RockTrue Science is designed to serve the intellectual need of fallen man while serving the desire for interdependence to better understand our physical world while still pursuing spiritual growth. RockTrue Science seeks to inspire, enlighten, and highlight upcoming and established local and international kings and queens of STEM fields while promoting Black consciousness and awareness of who we are and to whom we belong. Welcome, welcome, and good evening. We got a lot going, as y'all can see. We got a lot going on, all right, because we always moving in the kingdom, all right. It looks like I got like a little curl thing, but these are flat twists because I wash my hair, and if I don't do something with it, then the shrinkage is real. All right. So today we are going to talk about our group 5 elements, and those are they have a real technical name called the nictogens. It's a silent P in the front of that. Okay. But these are the nitrogen group elements. Technically they're group 15, going all the way across from the on the periodic table. However, we call them group 5. Technically it's group 5A, because they have 5 valence electrons, all of them. No matter how big the element is, it has 5 outer shell electrons that usually fill an s and a p orbital. So there's 3 that sit in an outer p orbital, and then 2 that are usually in another s orbital slightly inside of that. But we've talked about these electron orbitals before. So s orbitals only hold 2 electrons. So no matter how big the element is and how many electrons it has to fit into different orbitals, s orbitals will always only hold 2 electrons. Okay, that's how it works. So the larger elements like arsenic, which has a atomic number 33, so there's 33 electrons to fit into a space. 5 of those only sit on the very outer shells of that element, and 2 of them occupy an s orbital and 3 of them occupy a p orbital, and all of them share that. All the elements share that same characteristic. So at the top we have nitrogen, then we have phosphorus, arsenic, antimony, bismuth, and then there's a radioactive one that's not really stable. So there's, like I said, there's not a whole lot of data on the large ones because they tend to be very radioactive and don't really have any use, that much of a use to do any type of research or experimenting with it in this, to risk people's safety for it. And then they tend to be extremely rare. So there's that. And that one is unpentium. So yeah. And then plus, like, they tend to have really weird and really complicated. Hey, Selena. They tend to have really weird and really complicated names that nobody wants to say. Hey, Jonathan.
So he's pulling me away for some juice. So you know what that means.
Yeah. You got to put all the liquids in them.
Yeah.
And then time it and catch it.
You better
go to the pot.
You better. I'm gonna get a black eye. He didn't today twice already and peed on me. So.
Oh, did you pee on your foot and your shoe like my daughter did?
No, it's sitting on my lap.
Oh yeah, I haven't got the lap pee yet.
You haven't got lap pee. Oh, it's definitely.
She'll like pee first and then come and sit in your lap.
Oh no, this is him. He will sit there and let it roll and just not say.
Are you like, why is it getting warm?
Huh? What is that? What is that feeling? And then you look down, it's like, mother, nothing else. Okay, continue with class.
Oh, the joys of potty training, right? So nitrogen is an extremely abundant gas. It exists mostly as a gas unless super cooled to, I believe it's like negative 200 or 210 degrees Celsius. So that's really, really, really cold, and that's what liquid nitrogen um, is. So when liquid nitrogen, well, like nitrogen is liquid at negative 200 degrees Celsius. So that's why it's used for like super, super cooling stuff, freezing stuff, usually for like coolant tanks at power plants and things like that, because it does. It's really cold. And then its byproduct when it warms up is just regular old nitrogen gas that just makes its way back into the atmosphere. And we have a ton of nitrogen in our body, and we require it for all of our biological and life processes. Watching on TV, I know, right? Like, okay, I'm a show. And so nitrogen is important for all forms of life. And we get our main source of organic nitrogen from plants. So that's why eating plants is so important. Like, not to mention all the other types of nutrients that you get from it. But for the most part, the chemical compounds of those, the chemical makeup of those nutrients has nitrogen in it. And so a lot of phytonutrients and antioxidants are nitrogen based. And so that is why getting your vegetables is super duper important, because that is the only way we can actually digest it. So we breathe in, most of the air that we breathe in is mostly nitrogen. It's about 78% nitrogen. So, yeah, when you think air, you automatically think oxygen, but no, oxygen is the most important for us, but it's definitely not the largest component of the air that we breathe. However, we can't actually use it in that form. So yeah, that's like the catch 22. You get a ton of nitrogen, can't use any of it. Wow. And the same kind of goes for plants. So plants can breathe in, like not breathe, but they take in oxygen in the
Photosynthesis.
form of CO2. Exactly. In the form of CO2 and things like that. But as far as nitrogen is concerned, they can't, at the same with us, they can't just take it in from the air and use it. So they get it from their roots out of the soil, by nitrogen fixing bacteria. So nitrogen fixation is basically the making nitrogen in an organic form where
Mhm.
it can be used. And so plants usually get it in the form of a nitrogen, kind of like NO2 and things like that, with hooked on to some other stuff. But the bacteria is the ones that convert it from the N2 form to the NO2 and all of that. Because nitrogen, just like all the other elements in its group, it has those three valence electrons in its very outer P shell, and it forms extremely strong bonds with other nitrogen atoms.
Okay.
So when you see N2 as a compound, it's actually two nitrogen molecules with three bonds like this.
Okay.
And they're very happy like that. And the bond energy is extremely high. So it takes a biological process, hence the bacteria, to break those bonds. And they use the energy from breaking those bonds to power their biological processes and things like that. And then, they hook it on to some oxygen, and now the plant can use it for whatever it needs to do during this photosynthetic processes. The same situation with phosphorus as well. So, and I do have two videos, because I love my videos, and then especially with the natural cycles. So this was like probably like the number one way that we learned about all of these cycles in environmental science. So
Mhm.
the first one is the nitrogen cycle, and then the second one is the phosphorus cycle. I think there's a picture before that. Don't I have a
Did you send
picture
it
in
to
there?
me?
Yeah, it's in the email.
I didn't get that.
But yeah, so these bacteria are super important. And that's why, people are like, oh my gosh, bacteria, sanitize it. Not all bacteria needs to be sanitized. All right. And another nifty way that nitrogen is fixed, meaning brought out of the air into the earth, is lightning. So when lightning strikes through the air, it breaks those bonds. it's energy, so it can easily break those nitrogen bonds and help bind it to oxygen molecules in the air, and that also makes it usable by us and the plants. So that's yeah, and then that I know you've kind of noticed like when lightning strikes, or like if you're in an area where there's like really big thunderstorms, the air feels kind of different. That has something to do with it, because when the lightning strikes through the air, it is breaking that nitrogen up and making NO2, which has a slightly different situation going on. So that's why, it's always good to get out, get out in the elements sometimes. Don't be the tallest thing though when lightning is striking, because that's, yeah,
I'm so glad I'm short.
and don't stand near very tall things either, because you might get struck
Right.
residual stuff.
Right.
So yeah,
So it's not
rubber
always
shoes.
it's not always a smart idea to hide under the tree.
Exactly. Yeah, no, not really. So but if you're on the ground, if you're standing on actual grass and not concrete and ground, you have a better chance of surviving a lightning strike because
Hmm.
you're grounded. So yeah. But I think it has something to
Change?
do with like wearing rubber soles or something. It like
Right.
traps the electricity in your body. So that's not a good thing.
Right. Any
So being
chance?
barefoot is safer.
Yeah. Barefoot is safer.
Yes, because it allows the electricity to actually pass through you. The rubber stops it, so it doesn't allow it to actually leave.
Oh.
Actually go to ground. Yeah, 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 yeah. It gets complicated and weird. So best bet, don't get struck by lightning.
Okay.
And lightning strikes aren't actually what kills people. It's cardiac arrest. The electricity from the lightning causes an arrhythmia in your heart, so it makes your regular heart pulse. Your heart
Right.
has its own electrical pulse. It knocks it off balance.
Oh. So is it like a heart
It
attack
actually,
then?
basically, yeah,
Or
and it ends up stopping your heart. So
right.
if someone is there, fast enough to do CPR and get your heart back pumping again, you can survive a lightning strike. But
Right.
a lot of people tend not to, because
Yeah. Well,
they're
your heart
usually
starts
alone.
beating.
Which is, yeah.
Do you happen to have that video? I can go find it right because I didn't see it in my email.
Oh, did I send it to the right account? I sent
Uh,
it to rocktruth02@gmail.com. That's it.
yeah, you sent it to that account I don't have open.
Oh,
Not
oh, okay.
yet, at least. That's one of the I like to call that the dinosaur account.
Oh, okay. See, I wasn't sure which one I was sending it to.
Oh,
That's
okay.
why, because I just went with the one with the last one I got
Most
the
recent
email
one.
from. Yeah, that's where I was just sending the
Yeah,
stuff to.
that's the
Here, I could
real.
just forward it.
Okay, yeah, that's a real old account. Well, not an old one, but that's one of the first ones.
Okay. What's the right email?
Send it to RockTruth at Gmail.
Oh, she said she sent it.
She sent it. She sent it.
Yeah.
She sent it where? Do, 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 do. I just sent it. Looking in my email, I don't see what the thing
She just said, You turn my headphones down, Duda. Oh, to your email.
is. She sent it to my email,
Your personal email.
my personal email.
Yeah.
First, sent it to my email.
Oh, and so yeah, so phosphorus is the next one, and that's super important for life as well. Is found in basically all of our cells, and and used for a ton of stuff, and we'll definitely get into that. I'm just kind of doing a quick rundown. Arsenic, our favorite poison for
What's
all
that
things
about?
that we want dead.
I was always
And
thought arsenic is bad.
it is, because it's mostly poisonous. There's really no other use for it other than that, and it's a metalloid, so it might be used in like certain alloys and stuff like that. But for the most part, it's toxic.
Okay.
So yeah, you'll mostly find it in like rat poisons and pesticides and weed killers and things like that.
Right.
Um, Antimony is okay. So
Sorry, hit the button. I hit the button. They got a new like you don't know, but they got a new interface over here. So now all the buttons are
Oh,
in weird
is that
position.
the shutdown button? Like the show
No,
gonna end in like 30 seconds or something?
no,
Like
it's
defusing a bomb.
yeah, right.
It had like real dramatic, like
Yeah,
music. Like
yeah, I did.
what was that? Who Wants to Be a Millionaire?
Right. When and I hate it when they change interface because like when you're a production manager, like you
It's
get
like
so
where'd the
used
button
to
go?
right, and then it's like and you find it it's all the way at the back, so you start looking. Oh, it's this.
You
It's
just
so
start clicking
frustrating.
stuff. Like, what does that do?
Oh my
Oh,
god,
that's a new button.
it's like a new system altogether. Okay, so I'm adding these overlays. Hold on a second, so we can see what they look like.
Okay, and so antimony is another one of those elements that has a name that didn't really start out being its name, and so that's why its elemental icon is different. Yeah, yeah,
This is definitely
yeah,
weird.
but we'll be getting into that though. This is DNA, so
Okay,
of course we got to because we got it.
of course.
Um, so the SB is the what is the abbreviation for antimony, and as you can tell there are no s's or b's in the word antimony, so it's like why does it have that name?
Right.
So because oh yeah, this is the infographic the first one with all where it says group 5 and it's like green and white. That's the one I'm talking about right now.
This one.
No, it should be one before. No, that's the last one. It's like a couple of pictures before that one. It should be even before all the videos.
That's what she just sent me. So
Yeah.
ugh.
So it was used in a compound called stibnite in Egyptian eye makeup. So that's why it has SB because originally it was called stibnite, not antimony. I'm not sure. I'm very vague on why they decided to change the name. It's a couple of things, and then plus they stopped using antimony because antimony is a metalloid, and so it is slightly toxic to our body. So that's also why you won't find it in eye makeup anymore. But it had its purposes back then, especially in the very high desert heat and things like that. It protected their eyes and made everything not look so wavy. Kind of like football players when they put that black stuff. I
Yeah,
don't think there's any antimony in that. Like I said, I believe they replaced that compound with something else that's more organic and not so toxic.
okay.
But it's essentially the same concept. So the glare from the sun is reduced and you can see better. Bismuth is the only metal in this group. Arsenic and antimony are metalloids, meaning they have metal-like properties, but they are not true metals. So they're actually, And then bismuth is a metal, but it's a really crappy metal. Like it's not. Like it's the runt of the metal litter. Like so for that reason, it's used in some medical medicines and eye makeup and things like that. And it's not non-toxic, but it's not very toxic. So in small and moderate amounts, we don't actually absorb it into our body. So it's less of a worry of toxicity when used in moderation. So yeah, I don't know. I don't really wear makeup like that. And then like the little bit of eye makeup I do wear, I don't know. I haven't looked to see if that's in there. But pretty sure there's a lot of like oxides and things in it because oxides make the powdery substance for eyeshadow and foundation and things like that. So you'll probably find like some type of synthetic iron oxide in a lot of like face makeup and things like that. So getting into it, they form hydrides, oxides, and halides with our hydrogen, oxygen, and halogens. We haven't quite gotten to the halogen group yet. They're in that. Yeah, no, we got another group, but yeah, we got the oxygen group. So oxygen is coming up after nitrogen, so we'll be going through that. And then we'll be going through the halogens because they tighten off. But
Did you say they
this,
fight?
huh?
Did you say they fight?
Who fight?
The what'd you call it?
Oh
Halogen?
no, they tight. No, they tight. No, I
Oh,
love halogens.
oh, look,
Halogens
look.
have really cool chemistry
Like I
in
am down for what to witness this.
no.
There's a fight.
And so nitrogen is highly reactive with these things. So that's why they form these compounds very readily, especially nitrogen. Like I said, because it does have these triple bonds to itself, it is pretty happy, but those compounds tend to be way more electronegative. Yeah, electronegative. So they're more electron grabbing. So nitrogen will form compounds with those very readily, even though it's happy in its three bonded nitrogen molecule. Phosphorus does the same with those. Like I said, this whole group forms compounds with hydrogen, oxygen, and the halogens very readily, and that's usually what brings them into their organic forms. And a lot of the acids wouldn't be an acid. Yeah, I guess you could call it acid. So the acids that are formed with this group tend to be amphoteric. So amphoteric means means that it can,
Amphoteric.
yes, amphoteric means that it can act as both an acid and a base depending on the situation.
Okay.
And so equilibriums are reached very easily, quite readily, and this is useful in creating buffer solutions in things like our blood and useful places like that. Like you don't want your blood pH to change much because that will affect every chemical process that goes on in your body because your blood everywhere in your body. It touches pretty much everything except your brain because there's the blood brain barrier that keeps the blood off of your neurotransmitters and things like that. But other than that, your blood is pretty much in everywhere on everything, and you want it to remain its nice little happy. I think it's like 7.2 something pH or something like that. It's not quite neutral and not quite extremely basic or acidic, but these buffer solutions help our blood stay that way. So a lot of compounds in the group that I mentioned earlier, I believe it's the alkali earth metals play a role in this. And then phosphorus containing calcium phosphate compounds make up our bones. So about 70% of our bones is made up of this. And this is why phosphorus is super important because all of our cells are constantly being replaced, even our bones. You would think that your bones, once they're set, that's pretty much it. No, they are regenerating as well. And phosphorus is instrumental and very necessary for the. You was taking pictures with my phone. This girl just clicking and tapping. And
I'm doing alphabets right now.
right.
his new thing is he wants me to draw the alphabet for him and then he'll color it in.
Well, at least he's sitting and paying attention. She don't care about none of that. I try and read her. She's like, no, turn the page. Okay, well, what's that? No, turn the page.
Right. That ain't
and she ready to take the book, turn it upside down.
Right.
Like, all right, next book.
Like they read, I don't know, but so he got like a little stack of 10 books, like they just the beginner books, and he reads them so fast because he's saying the same thing over and over again. Like it says Jin Pen, and he's supposed to be reading Jin Pen does certain things. No, he'll just like Jin Pen, Jin Pen, Jin Pen. Jin Pen. Like, you got to actually finish reading the sentence, son. He's like, no, it's just Jin Pen.
Yeah.
Okay.
And so the uses, so we have and it would say nitrogen. So we will like I said, we can't organically use nitrogen as in its regular form as it is in the air, but we do manufacture fertilizers, which is the organic form of nitrogen to feed to the plants that we eat because we can't eat fertilizer directly because it's poop. So we don't want to do that. Okay. Plants like poop. We don't. All right.
We're starting to wonder, like, we're going, what's
So yes, we use nitrogen to make fertilizers, and that is how we get it into our plants so we can use it. And it's used in explosives. So TNT is a nitrogen compound. Is I forget the full chemical name for it because I'm not usually trying to blow stuff up. So I didn't retain that specific type of information, but it's like something nitro something. It'll come to me. And then phosphorus is used in safety matches and girl smoke bombs. So that's why smoke bombs have that kind of funky sulfurous kind of smell because phosphorus is actually usually there you go. It's usually mined from sulfur containing substances, and if you burn them, the sulfur burns off, and then you get that funky smell. But yeah, arsenic, like I said, mostly the ammunition. That's the metal alloy that is used in. Go figure. Like I said, arsenic, death. Like however you use it, death. Okay. Antimony is used in flame retardants and cosmetics. So, like I said, I think they're moving away from that a lot more. But like I said, I don't really wear makeup, so I can't tell you that for sure. And bismuth is used in X-ray shields and medicines because, like I said, bismuth is a metal, but it's a pretty crappy metal, but it's still a metal, and X-rays cannot penetrate any kind of metal. So it's useful in that manner, and that is it's a safe metal to use for that. And also because you can put it inside the human body, and like I said, we don't absorb a lot of it. Then when they're doing like internal X-rays on organs that they don't, because if you're doing like a bone X-ray, they'll put like a sheet or something over you, and then they'll just X-ray that area. But when they're trying to X-ray for different in certain areas, that can get a little bit trickier. So yeah, and it's flexible too. Like lead is not as flexible. So it'd be like wearing like armor. So yeah, bismuth is useful in that, and the medicine that it's actually used in is very common, and you know it as Pepto Bismol. So that's actually pink bismuth. And I believe that's like the main and like pretty much the only ingredient in it. Is like maybe something else, and if it's flavored, some flavoring. But for the most part, you're pretty much just drinking liquid bismuth. And I actually one time I scared the crap out of myself because I had chewed one of those Pepto Bismol tablets, and it was still, I guess, on my tongue, and I had went to sleep. I had a hangover. That's why, because that's why I went back to sleep. Yeah, and so I went back to sleep because yes, because my head hurt and my stomach was not feeling good. And then when I woke up, I had looked in the mirror and I was like, "Why's my tongue black?" So I scared the crap out of me. It was from the Pepto Bismol tablet. I was I don't even know how I realized like, oh wait, it was the Pepto Bismol. So yeah, it oxidized in my mouth and became something else, and it looked crazy. But it is
now you know.
exactly, yeah.
You gonna tell your kids that later on in life, don't eat Pepto Bismol and just leave it in your mouth overnight. It's not
Yeah,
good.
no, go ahead, rinse it. Go ahead,
Just
rinse
rinse
that.
it. Yeah,
Yeah, I started doing that because yeah, it freaked me out real bad. But when like I said, these form amphoteric acids. So when bismuth is used to neutralize acid, because it can be act as a base or an acid. So if you're in a very acidic environment, it's going to end up acting it. Get out the box. She mad that she can't get in the box and she's not even supposed to be in there. And so when it comes into contact with very acidic environments like your stomach acid, it acts as a neutralizer. So that's why it's very common found in antacids and stop. Thank you. It's very commonly found in antacids and your garden variety Pepto Bismol. It is also used in tandem with certain antibiotics to cure stomach ulcers. So the stomach, right, the stomach ulcers are mostly caused by a bacteria called H. pylori, and so it tends to burrow into the stomach lining, which is protected from the stomach acid, so it doesn't die. So, what they do is they give you an antacid to calm your stomach acid down because if you have a hole in your stomach lining, stomach acid is going to be very irritating and cause even more inflammation and exacerbate your problem. So, they give you the bismuth to calm your stomach acid down, and then you have your antibiotics to kill the bacteria and coat your your digestive tract and clear your body of all of that. But it does harm your good bacteria, your resident bacteria. Pretty much all antibiotics do that. So, excuse me, it's super important to keep an eye on that and take some probiotics. So get your kefir or whatever it is, your yogurts and things like that to help replenish your bacteria in your digestive tract. Which is also why if you're on antibiotics, the stronger the antibiotic, the worse the diarrhea. So that's your stomach, your digestive bacteria dying. And so when they die, you actually can absorb fewer nutrients. So that's why if you're on antibiotics for a long period of time, there tends to be like dehydration issues and things like that. So drink plenty of water. Make sure you're taking your vitamins. If you have like multivitamins and things like that, get as much of that as you can because your bacteria is going to be struggling while you're on those antibiotics, and you definitely want to have like a recouping um, regimen afterwards after you've completed your antibiotic regimen. When they tell you to take it for 7 days or 10 days or however long, take it for that long. For whatever reason they're giving it to you, take it. Just because you feel better doesn't mean no. Take it until the bottle is empty. If you
Yeah.
miss one, don't worry. Just take it at the next time that you're supposed to take it.
Yes.
And
Say
then
it
continue to
again
do
for
so.
people in the back, because clearly people don't be listening to this.
And when you don't take all of your antibiotics, what happens is that the reason why you were taking the antibiotics ends up still surviving, and it becomes antibiotic resistant. And then you have to take even stronger antibiotics, which is an even harder on your resident bacteria and your body system as a whole. So and then also now you've just created a new strain of antibiotic resistant bacteria that can infect someone else who probably doesn't have as strong of an immune system as you, such as elderly, children, and people who are already sick or immunocompromised. So, it's not just for you, it's for the greater good of humanity. So we're not taken out by an army of microscopic, assassins, because that's essentially what they are. You can't escape them, you can't see them, and you really actually kind of need them to live. So even if they do your body harm, trust me, they exist for a reason, and they were probably doing just fine wherever you picked it up from.
Right.
And on to the good stuff. So
Oh.
my favorite part about this group is nitrogen and phosphorus. As I said, they are essential to all forms of organic life. There is not a single cell that can live without nitrogen and phosphorus. And that is because dun, 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 it's in our DNA. So single cell organisms have RNA, which still use the same types of compounds. It's like it's one different amino acid, but it's essentially the same sets. So this is DNA. So this is what your DNA chain looks like in it doesn't give like a really good view of the 3D-ness of it, but actually some of those bridges are pointing out towards us and back away from us. So it actually looks like this,
Okay.
like a
Yeah.
crinkled piece of paper. That's probably a little bit more accurate as to what it actually looks like.
Right.
And the side it shows here is a major groove and a minor groove. That's characteristic of all DNA chains, and is formed by the way that the protein chains on the side fit
Mm.
together. And so, as you can see, I love that this is color coded. That's why I picked this picture, so that you can see the abundance of each element within a given DNA chain. And so the different types of amino acids are grouped into two groups, which are pyrimidines and purines. So that's all that is. So the pyrimidines are thymine and cytosine, and then the purines are adenine and guanine. And like I said, in RNA, the thymine is replaced by uracil. And phosphorus, as you can see, is a part of the DNA chain backbone. So the little yellow balls on the end, that's phosphorus making this nice little connection to oxygen and
Mm.
phosphate molecules. So that's why phosphates are important. Phosphate is the PO3, well, PO4 compound that is biologically active or is organic. So phosphorus is another one of those things that we can't use in its elemental form. It has to be converted to another organic form for us to use it,
Right.
and we usually get it from plants, from food that we eat, and yeah, that's pretty much it. And so it's also extremely important in what they call phospholipids. So phospholipids obviously is phosphorus. Lipid is fat. So it's um, found in chains called triglycerides, and those are usually found and those are usually found in our omega 3s and omega 6 fatty acids. So that's usually why it's encouraged to get those. We get a ton of omega 6s though in our crappy sad diet. So our standard American diet is chock full of omega 6s, which is actually an inflammatory fat when not balanced by omega 3s. So that's why you hear all this talk about omega 3, omega 3, omega 3, omega 3, because we actually don't get enough of it unless you live like in a port town and your meat in your diet is fish, because that's pretty much the best source of omega 3s is fish. You can get it from plants. You can get a plant source, which is ALA, this alpha lipoic acid. So that's what ALA is, and then you can get it in the organic fish form, which is EPA. So EPA and DHA are the omega 3 forms that are normally found in fishes, and that's also what basically is, for like brain function and development for kids, brain development, forming neurons, myelin sheaths, and the other things that help with neurotransmission and signaling throughout the body. So in our nervous system. So it is it's key. It is very key. And then there's also phospholipids found in cell membranes, which are used for active transport of things into and out of the cell. So your cell wall can be semi-permeable. A semi-permeable membrane means that only certain things can osmose or just diffuse into and out of the cell without using one of these phospholipid. Ooh, excuse me, channels. So, and a phospholipid can sit happily within your cell membrane because the inner wall of your cell membrane is actually a fatty layer that is hydrophobic, so doesn't like water, and you want something that can span that space without causing polarity problems and things like that. So because phosphates and things are amphoteric because of the characteristics of that group, it can be considered. Here she comes. It can be considered an acid or a base, or it can make Where'd it get changed from? And so once you get those things sitting in the membrane and the channels, Dora, what's the problem? And the funny thing is that I actually have. Hold on, let me grab this sheet. Sorry.
I see that Doc had to run away. I see why I had to run away. Mr. Jonathan wants Cheerios. Jesus Christ. Okay, dude.
Oh,
are these your best friends now?
Yes, it is. Actually, she just, man, look. When I found out she'll eat that, I was like, she'll eat it, and it has like a ton of different like nutrients in it and vitamins. I'm like, yes. Here, you want some more? Right. You want some more?
My problem is he wants to pour it himself every time. And I'm like, no, that's a mistake.
Yeah, because we had bought a big old box of them, but she wasn't eating them at first. And I was like, oh, no. And then out of nowhere, she was just like, oh, yeah, this is a cool snack. Yeah, I'm like, good. Here you go.
Right. Fire. Okay.
So this was actually my, not a cheat sheet, it's a study sheet. This is, I don't even know if these people still exist, but they probably do. This company been around forever. It's Bar Charts. And I knew about them from high school because they made charts for pretty much everything. Math, technology. I had a whole bunch for algebra, trig, calculus, physics. These sheets were my best friend. And so this actually has all of this stuff that we're talking about on here. And yeah, this was a big one. So this is all of this, and this is like just the quick look, the quick view information that I would need for my biochemistry classes. So it was really just a quick reference guide for a lot of different things for me. And
wait, that's the quick one?
Yes. It's that quick study. Trust me. It gets like and plus, a lot of this stuff I ended up memorizing. Yeah, this is like quick reference, like stuff that you would probably forget, like constants, different type. Like this is the Michaelis-Menten equation. Like I don't even remember. I did use this before, and I forgot when I used it. It's been a minute, but it has something to do with kinetics of a reaction, and I haven't had to thankfully use that equation too much because in biochemistry we did in advanced biochemistry we did have to do some equations and stuff like that, but for the most part most of the science math that I had was like calculating acid base concentrations and things like that. So that was probably like the largest extent of it, but yeah, it could get hairy real quick. And so having something like this on hand was like great. But a lot of this stuff, like this page was probably something I probably had more so memorized. So this is like structural things like with sugars, the sugar structure for because that's a part of this DNA backbone. That's what DNA stands for, deoxyribonucleic acid. So deoxyribo is a type of sugar. So it's ribose. So anything ending in ose is a sugar. So cellulose is a cellular sugar, like sugar cell. And fructose is a sugar, glucose. So anything ending in ose is a sugar. And so furan is actually the 5-member ring of that ribose sugar, and it's called furanose. And then you have your deoxyribose is basically one of those OH groups that's on the ribose sugar is gone. So it's just a hydrogen. So that's what deoxy means, like taking away an hydroxide group.
Okay.
Yeah. So and that kind of makes you wonder, is like, so if you're taking away, so which came first, the RNA or the DNA? Ding ding ding. RNA actually came first. So deoxyribonucleic acid is only found in multicellular organisms, and multicellular organisms are more complex. So the simpler came first, and then was complicated. It was thus complicated afterward, and so when things like viruses, so a virus is something that carries nothing but RNA. It doesn't really have any cellular organelles or anything. It doesn't really have its own source of energy or any of that. It's literally just a package of genetic material that is the only thing it has turned on is get to this host, duplicate, and go. So it doesn't have any other type of information to tell it what to do or any of that. It doesn't divide, multiply, or none of that until it gets into a host, and then it hijacks that host cell's workshop manufacturing plant to build all their own stuff. So that's pretty much the whole thing with RNA. And then also RNA is used by multicellular organisms, mostly with transporting genetic material outside of a cell. So the DNA never leaves the nucleus of a cell ever for any reason, unless the cell is attacked, broken, or sick. Like something is wrong if you have genetic material outside of a cell. And so what it does is it makes a copy of it, and it's called mRNA. And so the messenger RNA, that's what the M is. The messenger RNA takes this material, the genetic material, and that's when it just recodes. So like I said, the T is actually a U in RNA. So that's what it does. The DNA chain breaks open into its two halves. The mRNA comes in and it makes a little copy of itself, and it changes the T to a U. And that's how that's how the nucleus knows, okay, this isn't DNA, so it can leave the cell, the nucleus. So once it gets outside of the nucleus, or do I have this backwards? Maybe it's the tRNA, because the tRNA transfers it. So the tRNA comes in, makes a copy, and then it gets to the messenger RNA that brings it back together inside of a new nucleus. And it's like, oh yeah, so now we're making, and it converts it back to DNA based on how that syncs up. I'll have to find a video for that too. Because that's something cool to watch. It's been a minute since I've actually gotten into all of that, because like I said, this stuff, man, this I'm looking at it, was a whole lot of hate. Like I used to know all of these. This whole list, all of these are the amino acids that make up DNA. I knew all of this by heart, like the structures and the different active groups on it that made them because it made doing problems and stuff quicker than to have to. But yeah, so that's why you have a sheet like this. And then when you're doing, because I took genetics, and this is what this page was super useful for, was my genetics class, because they don't put out chains like this, because it's real complicated. It can get really complicated when you're just trying to look at a really long chain and stuff, and you want to see the pattern. So the genes are coded by 3 letters. So each letter would be, oh yeah, some of these have other things mixed in, but each letter would be like the first letter of one of these amino acids that are coded for in RNA. So is that, oh yeah, so cysteine codes as, so that's the gene coding for cysteine. So it's UGU UGC. So yeah, like I said, it gets complicated, but when you're in it and you're like, it makes sense. So but yeah. Oh, did you find the videos for so we'll show the videos now for the nitrogen and the phosphorus cycles.
I got the nitrogen cycle first. Is that cool?
Yeah.
Okay, hold on. Let me drop this down. This comes on. Nitrogen cycle. Nitrogen cycle. Oh, right.
Nitrogen is essential to life. Plants and animals need nitrogen to make proteins. Proteins are the building blocks of cells and therefore life. Nitrogen makes up 78% of the air, however, neither plants nor animals can take nitrogen directly from the air because nitrogen is so unreactive. However, plants are able to take nitrogen compounds such as nitrates from the soil, and then animals eat these plants, therefore providing animals with a source of nitrogen. In this video, we're
Oh,
going
we
to
can't see it.
the cycle. This is the movement of nitrogen through the environment. Nitrogen is continually cycled through the air, soil, and living things. The process of nitrogen in the atmosphere.
You said you can't see it?
We can hear it though.
That's weird. You should be able to see it. Okay, let me try it again. Hold on. How about now?
Nope, it's just me up there. Oh, it's something loading on the side.
Oh, it's loading. Oh no. Okay. How can I do this?
Yeah, is that you having the? Because I keep getting a warning that my internet connection is shaky. Stop, bro.
Yeah, because I'm playing it, and I don't know if it. I don't. It's playing on my end. Uh oh. Oh, Twitch is having a hard time streaming this, so I don't know what that means. Okay. All right. Is it still loading on your screen?
Yep.
Okay, hold on a second. Let me back out of it. How can I do that? Can I do that? Yeah, I can do that. Do.
And then watch on the beat show, something about DNA gonna come up.
And I would be like,
Chris always be like, I swear I didn't plan this.
how is this happening? Okay, can you see anything yet?
Nope, it still just got the little circle loading.
That's crazy. Okay, let me turn this off, and then try again. Share audio. Close Chrome tab. Do I have just too much stuff open? I might just have too much stuff going on one time here. Do. That. I need that. Okay. That. Okay, how about now? No. What?
It's still the Rock Truth Forever 21 and the little loading circle.
That's weird.
Oh, show the picture of bismuth. So this is actually elemental bismuth, and it does look this like psychedelic under different.
It's in a different screen. Got a lot of things going on here. Can you see that?
Nope, that's loading too.
What? What is happening right now? It's still loading?
Mm-hmm.
Why? Why today? Okay, hold on. Let's try this then. No. Where's the thing? Oh, I didn't put business on this. Hold on a second.
Okay, I did have that right. It is mRNA that converts the DNA to RNA, and then the tRNA and the transfer RNA is what actually is coded for proteins. So when proteins come and get their information, they're made from tRNA.
Editing on the fly.
And another nifty thing about nitrogen, so the compound that's the reason why they're called amino acids, because they are amines, which refers to their nitrogen bases. So the nitrogens in the girl, what are you doing? Don't do that. Don't do that. So, so the nitrogen in the bases are what helps form the bonds between the amino acids in your DNA chain that holds the chain together. Ooh, excuse me. And so when those bonds are broken to open it up, energy is released. So uh, coding and making proteins, that's why it's a very energetic process, and requires a lot of energy as well. So that's why phosphates are super important as well, because as we mentioned before, when we were talking about muscle contractions and things, when we were talking about the electrolytes for our muscles, phosphates are what make up the adenine diphosphate and the adenine triphosphate molecules that are used as cellular energy. And cells that usually store energy are nitrogen and phosphate based as well, for that very reason, because of those strong bonds that they tend to make with with hydrides, oxides, and halogens. Don't go pushing stuff. Look, you about to close the screen, bud.
Did it load?
Nope, it's still a little circle turning.
Oh, because I have it on my screen over here. So what? I hate to say this. I think it might be your internet connection.
Oh, it might be mine. Oh,
Yeah.
so it is popping up. Yeah, it is popping up saying that.
Okay.
So yeah, if you can see it, go ahead and play it, because I don't need to see it. I already know.
Watch it. All right, hold on. Now I gotta pop out of this screen and pop into that screen. And then you said you could hear it, right? So.
Yeah, I can hear it. I just can't see it.
All right.
Nitrogen is essential to life. Plants and animals need nitrogen to make proteins, and proteins are the building blocks of cells and therefore life. Nitrogen makes up 78% of the air, however, neither plants nor animals can take nitrogen directly from the air because nitrogen is so unreactive. However, plants are able to take nitrogen compounds such as nitrates from the soil, and then animals eat these plants, therefore providing animals with a source of nitrogen. In this video, we're going to look at the nitrogen cycle. This is the movement of nitrogen through the environment. Nitrogen is continually cycled through the air, soil, and living things. The process of nitrogen in the atmosphere being turned into nitrogen in the soils is called fixing. Here are 4 different ways in which nitrogen fixing occurs naturally. Firstly, nitrogen fixing bacteria in the soil turns nitrogen from the air into nitrates, which the plants can then absorb. Some plants, such as the legume family, which includes peas, beans, and clover, have these nitrogen fixing bacteria in their root nodules. Secondly, decomposers in the soils break down animal excretion and dead organisms, returning nitrogen back to the soil as ammonia. The ammonia turns first into nitrite, then nitrifying bacteria in the soils turns the nitrite into nitrate. Thirdly, lightning can cause chemical reactions in the atmosphere, resulting in nitrogen reacting with oxygen to produce nitrous oxide. The nitrous oxide then reacts with more oxygen and dissolves in rainwater to make nitrous acid. This rainwater containing nitrous acid increases the amount of nitrate in the soil. Burning fossil fuels also adds nitrous oxide to the atmosphere, resulting in nitric acid. But this is, of course, not a natural way of nitrogen fixing. And finally, in the oceans, many species of blue-green algae, also called cyanobacteria, can fix nitrogen. This then provides sources of nitrogen to aquatic animals. And the nitrogen goes around a similar cycle to what happens on land. These are the natural ways through which nitrogen fixing occurs. The Haber process, which is how fertilizers are made, makes up approximately 30% of the nitrogen fixing. Because nitrogen is essential for making proteins, proteins are essential for cell production. Cell production is how growth occurs. Fertilizers are therefore used to increase the nitrates in the soil to maximize plant growth. Watch our videos on the Haber process to learn more about this. And as I mentioned earlier, burning fossil fuels also adds nitrous oxide to the atmosphere, which dissolves in rainwater to make nitric acid, which then adds nitrates to the soils. This isn't as good as it sounds. It upsets the balance of the natural nitrogen cycle, polluting ecosystems and altering the ecology of entire regions. Too much nitrogen in the soil makes it more acidic. The nitrogen also passes into rivers and lakes, where it is considered a pollutant. In some conditions, such as waterlogged soils, denitrifying bacteria in the soil break down nitrates and return nitrogen back to the air. This reduces the fertility of the soil. So from this video, you should now understand how the nitrogen cycle works. Nitrogen is essential to life, and so needs to be fixed in nitrates for plants and therefore animals to access it. Nitrogen is continually cycled through the air, soil, living things, and water systems.
Okay, and then the phosphate one.
Right. Phosphate. No.
Welcome to Moo Math and Science. In this video,
watch on YouTube.
I'd like to talk about the phosphorus cycle, along with water, carbon, and nitrogen.
Okay, sorry about that. It's playing auto YouTube here.
The playlist.
Yeah, it's like just going, and I'm like, slow down, wait for me. Okay.
Welcome to Moo Math and Science. In this video, I'd like to talk about the phosphorus cycle, along with water, carbon, and nitrogen. Phosphorus also has a biogeochemical cycle. However, it is different in one way. Phosphorus is not found in the atmosphere. Phosphorus is very important for cells for the production of ATP. It also forms the backbone of DNA, and it makes up our cell membranes. Phosphorus is found in rocks. Weathering, along with rain, breaks down the phosphorus in rocks, and it travels to the soil. Once in the soil, plant and other producers are able to absorb the phosphorus. Some of it also makes its way to the ocean and fresh water. Animals then eat the plants, and the phosphorus moves into the animals. Inside the animals, the inorganic phosphorus is converted to organic phosphorus. Animals excrete waste, and decomposers are able to use the phosphorus in the waste material. When the plant and animals die, the bacteria may convert the organic phosphorus into inorganic phosphorus in a process called mineralization. Some of the phosphorus in the soil gets washed to the ocean, where a similar process takes place. Plants absorb the phosphorus, animals eat the plants, and decomposers absorb the phosphorus from waste and decaying matter. Some of the phosphorus gets buried in settlement, which over time becomes rocks, and the cycle continues. There's the phosphorus cycle, another biogeochemical.
I don't think he know we can't hear it because he muted it.
Moo Math uploads to New Math and Science.
But it's cool.
Please subscribe and share.
So I double checked that. Oh yeah, Will. Oh, he's back. He's back. Will.
Okay, so in this video, we're going to look
I got
at
it.
the phosphorus
Oh,
cycle.
oh yeah.
One thing I want to mention is that
I don't think we can hear
the
it.
phosphorus cycles through
What's going on now?
I don't know if we could actually. I don't know if we could still hear when we muted it because I was listening to it from your computer. So when you muted, I couldn't hear it.
Oh, when I
I
muted
can't hear the video. I don't know. Yeah.
it? Okay. Well, it was like right at the end, so
Yeah. That's what I was saying. It was fine
Yeah.
because it sounded like he was pretty much done. He was just saying like some other forms of like phosphorus in the thing. But I was looking, and I was right. So the mRNA is the one that goes into the nucleus and comes out with the stuff, and that's how your proteins are made. So the ribosomes that are located in the little reticular form, I forget what that's called. I haven't studied cell structure in a very long time. Okay, that's like first level biology, like all of the biology classes up until like I don't know, like your sophomore year in high school. We'll probably talk about the same thing, which is cell structure and they leave out different parts. They start adding more and more parts to the cell that they talk about. And I think like high school is when they get to like, you pretty much have all of it, and then after that it just gets more complicated via the processes and stuff that they actually talk about, and the compounds. And then like when you get to college and they want to, you know, give you an internal migraine, then you have to know all of the actual like chemicals and the different names of like every single amino acid. So that's what that list was. That's what this list is. This is the list of all the amino acids in the middle. It's hard to do this from but this is a list of all the amino acids that make up proteins in our body. So all the proteins in our body is on this list. And then the coding for the C, the C, the A, the U, the G, those are the DNA or the RNA amino acids. So there's only 4 DNA amino acids and 4 RNA amino acids, and the rest of them are general protein amino acids. And you won't find DNA or RNA amino acids in those links, because that's what's used to code for the other protein amino acids. And nitrogen and phosphorus are all up in the mix, doing all the doing, and and promoting a lot of these the formation of pretty much all of these compounds. Like I said, that's what amino acid literally is. It's an amine with an acid group. And so yeah, like I said, they're amphoteric, but in an amino acid's case, it acts as an acid. So, and then in DNA's case, they are bases. So they act as a base as opposed to being an acid. That's why they call them DNA bases or nitrogen based compounds, because they're acting as bases. And then to wrap it all up, what was I? I just had a major brain fart. Like I've had a low level headache like this whole time, and I just like literally had a major brain fart right here. All right, so to wrap it all up, and I loved, like I said, having videos for those cycles, because it helps to see where this stuff is coming from, where it's going, how it's being used, because we're not necessarily physically in any of those spaces or able to see it visually with our own eyes. So it always helps to see see it all put together, and then you can kind of figure out how you fit into that cycle, what it is that you're doing to help promote the cycle, keep it going forward, and maintain it in a healthy and sustainable way. That's what sustainable is that it's a cycle that can continue to go, and non-sustainable means it ends when you throw it in the trash. So that's what we want to try and aim more for, is cyclic use of things, and cyclic creation of things, so that it's not just over and done with, you toss it in and then you have landfills filling up with all kinds of stuff, and that's a whole nother problem in itself. And like I said, now that there's more environmentally conscious regulations and stuff in place, some things are getting cleaned up, but there's a lot of things that's already been done in the wrong way and forgotten about, and we are still paying the cost for a lot of that. As we can see from Flint, Michigan, still not having clean water. Last time I checked, they still don't have drinkable water, and not even just drinkable water. Like, your skin is the largest organ on your body, and water is probably the only thing that can diffuse across it more readily than pretty much anything else. So with different temperatures, so like if it's hot, your pores will open up. Water can diffuse directly through your skin into your body. And if it's unclean water, contaminated water, that makes you very susceptible to a whole lot of things. And a lot of stuff that's dissolved in water can be carcinogenic. So carcinogenic basically means cancer causing. Just like what was that? I thought I wrote it down, but it was one of the compounds we were talking about today. I want to say it's antimony that's carcinogenic, and so that's why I was saying that it's probably not a good idea to use makeup and yes, defend the land exactly, because that's why I love showing these cycles: the nitrogen cycle, the hydrogen cycle, the phosphorus cycle. What else am I? Nitrogen, oxygen, the carbon cycle. All of these things are all essential to life. And as you can see, the only way that we can access it is through the land. Plants are the only thing that makes any of these elements useful to us. So that's why it's super important that we protect it and we take care of it the best way we know how. Like I said, having your own garden. I have a little mini garden on my balcony. Some of the stuff died. I wasn't I was it didn't work out. But I will not give up. I will replant. We will replant and we will try again, okay? So I still got a ton of seeds and I'm like looking up stuff that I can plant for the fall, and that'll do well throughout the winter and everything. I can pull my stuff indoors and I can just grow it indoors. So I'm still researching stuff like that. But any type of green, leafy anything is, trust me, is cleaning the air that you're breathing, is helping the environment. Even if it's a contained and controlled environment in a flower pot somewhere, trust me, it's useful. So grow something. And then it also helps you get more familiar with plants, their, how to take care of them, their life cycle. And then the more you get into it, you can learn more chemistry, because plants mostly like with phosphorus. So plants can't actually use phosphorus in acidic soil or really basic soil, because like I said, phosphorus is amphoteric. So it can act as an acid or a base. And so if it's in very acidic soil, it will end up binding more to the minerals in the soil than it will be able to be used and drawn to plants. And the same at very basic pHs above pH 8. So you want the soil to stay between a pH 4 or 8 for the plants to be able to absorb phosphorus. Anything outside of that range is going to sap the phosphorus away from the plants, and then they won't flower. So if you have a flowering plant and it's not flowering, you may want to check the pH of the soil, because it's probably too high or too low. And they won't grow and flourish. So new buds and new leaves and things may not sprout out as often. Things won't grow as big. If you're doing like agriculture, like you want crop yields and things like that, when you're doing that, then your crop yield will be reduced if your plants aren't getting enough phosphorus. So like I said, it's super important to life in general, and plants are our only conduit to that. So we have to keep that in mind and stop treating them like they're a commodity, when they're the lifeblood of this planet and for us. So we can't survive without plants, but plants can definitely thrive without us.
Yes,
So
again.
so we definitely gotta remember that we're all connected, and that's why I love how all the useful things to life occur in cycles.
Right.
So we cycle as everything else organic and living cycles. So I will leave you all with that, and I'm gonna tune in with y'all to Rock True Beats, because I see Marley Kingdom popped up. Okay.
Yes, already on.
So hopefully I've inspired some other type of conversation to be had, because it's always interesting to see how it ends up tying into music, and he definitely always finds a way
Yes,
to tie it into music, and it's always something very enlightening and mind expanding. So I'm excited to see what's up next. At it's 8 o'clock Eastern, so I'm Eastern, and it's 7 o'clock Central time. So definitely tune in. Next week we'll be talking about the oxygen group. Like I said, we all are very familiar with oxygen, but there's other things in the group that we may not be as familiar with. So I can't wait to talk about all of that. And then I'll also probably present the experiments that we'll be doing the following week, because we have 5 Tuesdays in this month. Yes. So usually I do the experiments on the third Tuesday, but because we have that extra Tuesday and it falls kind of funny, I decided to push it back to the 20. I think it's like the 24th or something like that. So yeah. So tune in about 45 minutes for RockTrue Beats, and then I'll see y'all next week, same time, same place, where we rock truth or nothing at all.